Today we're going to be going over the properties of square roots. First, let's go over what a square root is. A square root reverses what you do when you square a number. So say, for example, you have 6 squared. That's going to be 36. Now let's say you have the square root of 36. It would reverse what happened up here, and so the square root of 36 would be 6. Think of it like addition and subtraction, or multiplication and division. Now, there are some numbers like 16, 4, 36, 81, and so on that are perfect squares. That means they come out evenly. Like the square root of 36 is 6, the square root of 81 is 9, and so on. There are other numbers that aren't perfect squares, which means they don't have one integer that multiplies by itself to get that number. So let's say, for example, you have the square root of 18. There isn't one integer that multiplies by itself to get 18. So what we're going to do is make a prime factorization tree. We're going to start with 18 at the top, and then split it off into 2 different factors. You want to get the lowest number that's more than 1. So I know that 2 goes into 18. So we're going to put down 2, and I know that we're going to need to multiply that by 9 to get 18. Now 2 is prime, so you can't go on any longer on that side. But we know that 9 does have a perfect square. 3 and 3. And see, you want these duplicate numbers. What you're going to do is put the duplicate number outside of the square root, and then put the number that only appears once inside. Now you can simplify this into a decimal, but this is usually how you write the final answer. The first rule we're going to be going over is the product rule. So the square root of AB equals the square root of A times the square root of B, and vice versa. So say, for example, you have the square root of 5x times the square root of 10x. You would multiply what's inside according to the rule. So you would multiply the 5 and the 10, which is 50, and multiply the 2 x's, which is x squared. You can make a prime factorization tree for 50 and have the square root and the x squared cancel out, but this also works as a final answer. The quotient rule is the second rule that we're going to go over today. The quotient rule states that the square root of A over B equals the square root of A over the square root of B, and vice versa. So say, for example, you had the square root of 9/16. All you would have to do is the square root of 9 divided by the square root of 16, which is 3 over 4. Now let's apply those 2 rules to the nth roots. So the nth root of AB equals the nth root of A times the nth root of B. And the nth root of A over B equals the nth root of A divided by the nth root of B. Let's do the cube root of 40. So we're going to need to make a prime factorization tree for this one. So 40, 2, 20, 2, 10, 2, 5. And since this is a cube root, we're going to need a number to show up 3 times, which in this case is 2. Then you would need to make sure that's a cube root. Let's do this example too. Again, we're going to need to make a tree. And we have that triple duplicacy. Now, let's move on to exponents that are fractions. So if you have a to the 1/n, that's going to be the nth root of a. So say you have 4 to the power of 3 halves. you're going to put the 2 as the root, so just a normal square root, put the 4 inside, and make the entire thing have a power of 3. And the square root of 4 is 2, and then 2 cubed is 8. Now let's do 32 to the power of negative 2/5. So this time you'd end up with the 5th root of 32 to the power of negative 2. So if you put this into the calculator, or if you just know it by hand, the 5th root of 32 would be 2. Now remember, if you have a negative exponent, you have to put it in fraction form. So 1 over 2 to the 2nd power, which is 1/4. Now let's move on to a very important concept that you're going to need in pre-calc, which is conjugates. Conjugates are used to rationalize denominators. So to conjugate something, you just need to multiply the fraction by whatever is needed to get rid of the root in the denominator. So say you have 6 over the square root of 12. To get rid of the root in the denominator, you're just going to need to multiply by the square root of 12. So the roots in the bottom would cancel out, so you'd end up with just 12. And in the numerator, you'd get 6 times the square root of 12. The 6 and the 12 can simplify to the square root of 12 divided by 2. And then you could simplify the square root of 12 further, but I'm not going to do that here. Now let's say you have 8 over 4 plus the square root of 5. What you would multiply this by is 4 minus the square root of 5. So basically you would just change the sign. And again, whatever you do to the denominator, you would need to do to the numerator. So the 4s would multiply, and that'd just be 16. And the square roots would cancel out. So it would be minus 5 over 32 minus 8 times the square root of 5. You would end up with 32 minus 8 square root of 5 over 11. And that's all for the properties of square roots. And as always, I'll be leaving Khan Academy practices in the description of the video. Thank you for watching.